Ankita. Good morning, Ravi. And good morning, everybody.
Good morning, sir. Good morning, everybody.
Good morning, Boji.
Good morning, sir.
Let's start, Ankita.
Yeah. Good morning, everyone, and I welcome you all to the AI and Data Science in Manufacturing Meetup. So I am Mrs. Ankita Pai Nayak, Professor, AG School of Data Science. I would like to welcome our dignitaries for today, Dr. Abhijit Gangopadhyay, Dean at AG School of Data Science, Mr. Bhupesh Daheria, Founder, MUNI Campus, AI, Data Science, Thought Leader and Speaker, Mr. Avnish Kumar, Founder and CEO, Live and Sense, Mr. Aniruddha Banerjee, co-founder, Switch On, Mr. Ravi Ranjan Prasad Karn, a proud alumni of Aegis, principal product developer, BMC Software. We are thrilled to have you all today here as we explore the latest trends and technologies in the field of manufacturing. This meetup will focus on the crucial role of AI and data science in transferring the manufacturing industry. Over the years, manufacturing has evolved significantly, and today it's being reshaped by new technologies and data-driven insights. That advent of AI and data science has opened up new opportunities for manufacturers to optimize their processes, reduce costs, and enhance the competitiveness. Through this meetup, we aim to bring together industry experts. We have data scientists, we have AI enthusiasts to share their experiences and insights on how AI and data science can revolutionize manufacturing. We'll hear from some of the leading experts in the field and we'll discuss the latest trends and technologies. We hope this meetup will inspire you to explore new possibilities and empower you to leverage the power of AI and data science in your manufacturing operations. Thank you once again, everyone, for joining us today, and we look forward to an insightful and engaging session. Now, I welcome Dr. Abhijit Gangopadhyay, Dean, AG School of Data Science, to start with the keynote. Over to you, sir.
Thank you. Very good morning to all of you. Thank you, Professor Ankita. It was wonderful to join you in a session like this in terms of manufacturing AI. I think as I summarize this age is not a manufacturing, because it was basically, we have a major shift. It was in our early span of career, we had manufacturing industry, and that used to really thrive on many things. And if I recall the history of human organizational management, I think basically manufacturing was the key thing which was evolving around. Now, what has actually happened? One of my guru, management guru, he really summed up in this way. Earlier, it was a first of all, it was a mechanical era, then came to the manufacturing era, long assembly line and assembly concept. And then subsequently, it hived into a knowledge era. And I think this knowledge era is essentially making the entire management process as with a lot of power from which has drawn from the technology, especially information technology. And that has resulted in lots of development, which I think probably is the key for today's meetup. I think I have nothing to encourage or discourage you. Is a thing which is going to happen in any evolutionary process of any society. But I have few concerns, and I think I'll be happy that all ex-practitioners, those who are participating in this, could throw light on this. And it was essentially, if I look at it in a very simplistic term, I think it was early of this 19th century when we developed a assembly line technology for manufacturing. And it was an exciting moment because one of the objectives of managing an organization was to make organization to have marginalization in terms of the cost and operation. Now, if I think about the marginalization of cost, I think what has actually happened, then if we can mechanize it, it will definitely eliminate the cost and make the production line very efficient. And I'm very happy that which has started through this era, through the operation of the Ford Motor Company, which started manufacturing cars in terms of the assembly line. But it was a very primitive assembly line with a very short span. Gradually, this assembly line on manufacturing technology started going in a very long assembly line, and probably nobody was knowing what is happening in terms of, but ultimately it used to result into a lot of marginalization in terms of the cost management. And if I today understand a very simplistic way, everybody would like to reduce cost, I think, and this is an objective. If we can reduce the cost, I think naturally everybody is benefited. Organization gets the benefit. And therefore, if I talk about the traditional way of managing, be it a cellular manufacturing technology, modular manufacturing technology, all these concepts we have experimented over the years. But now the time has come, and probably what has actually been very, very alarming, when we start introducing robotization and use of artificial intelligence, which is a ground reality in terms of every organization trust. But it has lots of other issues which probably need to be addressed. The moment we use AI is a wonderful technique and a tool and concept and technology. But what has actually happened, if I have too much of application of artificial intelligence, I think essentially you are trying to undermine the importance of the natural intelligence. But besides that, what will happen again, if there is a, say for example, if I today think about applying this concept in manufacturing sector, what will happen? It will produce flawless products, but it will be devoiding of any human touch. And what will happen also is that it will slowly reduce the number of people, those who are engaged in any organizations, whether it's a multinational organization, domestic organizations, or any place. And what is happening, the skills which people used to attempt, I think will be taken away. I had an opportunity of visiting assembly lines of many manufacturing organizations in all over the world, especially in the emerging market in South and Asia Pacific areas. Now I have seen one of the, say for example, we take the example of the these Mercedes cars. Now I have seen that this is, when it comes to low level of Mercedes car, still artificial intelligence, robotizations, and probably these IT concepts are being widely used. But when it comes to exclusive cars of Mercedes model, I think still the management is not interested in passing on to, say, S-class cars are still manufactured by the individuals. So they don't dare to apply it. What actually happens that if you make anything artificial intelligence driven, the softer touch, although we may claim, and claims are being very loud in that, then if we have NVIDIA's concept of deep learning or every technology, now we can have the sentiments attached to the manufacturing technology. But I am really skeptic, and I think people have reason to be skeptic, because I have seen when it comes to exclusiveness, they don't use. So if I today think about manufacturing of aircraft engines, be it by White and Whitney or anybody, Boeing, Airbus, finally, all their engines are manufactured by, they are not fully automatized. And that gives rise to a controversy. What is the possibility of application of artificial intelligence? Now, it's very fine that everything we can codify and then subsequently apply it through the principles of machine learning and further refined processes. But what will happen eventually, it's a very skeptical way of looking at the things, that human beings eventually will lose control on everything. Now, if that be the reality, I'm not. I think we have lots of colleagues who are practitioners in this area. They will, and I'd like to listen to their views on that. But my first question will be, what is the extent to which we can use artificial intelligence in manufacturing technology? I have seen major drug manufacturers at the end of it still use the human being in the assembly line for screening the rejections. You see, when you manufacture a drug, the percentage by which you reject the product is essentially human. It's a human component, because in number of cases we have seen to a statistical concept, I think you cannot continue to really depend on a machine for eliminating all error. If I talk about healthcare sector also, the same problem is coming. Whatever you may be doing, at the end of it, I think 0.01% maybe the robotic surgery fails. And at that time, you have to have a monitoring by human beings who are conducting the surgery. Now, what is happening? Artificial intelligence, or for that matter, every innovative technology will have robotization, artificial intelligence. All these things will ultimately will be under surveillance. If you talk about automatic landing system of an aircraft, still we need to have one pilot and co-pilot. It need not be a 16 team of crew members to drive to conduct a flight. But this is what exactly will be happening in the years to come. So my hope for this meetup is to, because my young colleagues are very keen in learning artificial intelligence, is a buzzword, and then use it for everything which is available on Earth. Now we have to always accept it with a grain of salt. Now the conventional manufacturing technology, you see, it was a very elastic sense when the entire processes were automatized. Now we are trying to automatized with the human being. Now, what is happening? We have experimented with modular, cellular manufacturing technology, but everywhere we have to monitor that there is a degree of error which also creeps in. Now, how to reduce that? It is very promising that if I have artificial intelligence fully deployed in a manufacturing sector, now error will be very marginal. But each error can be critical also, especially in terms of having the reported deviations. Now, statistics is nothing but analysis of, or mathematics is nothing but analysis of such deviations in a large number of cases. I feel that this is a very wonderful approach with a little bit of caution, and I'm probably the technology expert. I am not a technology expert, so I won't be able to comment on that. It can be further redefined. Until that time, now I think we have to use it carefully. But especially my young friends, those who are opting for a career in artificial intelligence, you have to understand one thing, that this career is really rewarding, and I think it is worth, because essentially what you are doing, you are trying to manipulate data in a flawless pattern through the technology interface. And it's a wonderful opportunity for all of you to build a career around that line. I think what is happening, I am talking about one side, which you should not take it very seriously, because the other side is that unless you automatize it, unless you use the artificial AI techniques, what will happen? Major part of the data remains unexplored or unanalyzed. It's a wonderful technology, which probably is giving us a new horizon. And with this hope, I think we have I think I'll be there. With hope, let us discuss about the feasibilities. I'm not trying to encroach on anybody's wisdom on artificial intelligence. But essentially, it is again, see, even if intelligence has a lot of natural intelligence has a lot of components of artificial intelligence. Say, we are also subjected to machine learning, deep learning, everything. Say, for example, the way we have learned is nothing but a very rudimentary form of artificial intelligence. Now you are fine-tuning it and making it a totally different phenomena in terms of applying it in managerial efficiency. So at the end of it, this will provide you a wonderful career opportunity, wonderful benefit to the larger society and business. And if it is possible, I think it is, and it is already possible. And it is not possible. It is already possible and activated. So I wish today's meetup will throw open a lot of challenges, and probably that is what I wanted to say, and wish a great session for all of you, a meetup session in terms of the artificial intelligence in manufacturing technology. Say, for example, today, manufacturing economy is going to be one of the key determinants of the growth. And if that will be so, because everything has to be manufactured, and therefore, whether it's a microchip or anything, you see, even I have seen the way it is moving. Say, for example, when it comes to chip manufacturing, also you are using a lot of artificial intelligence technique. With this, I wish all of you a great sessions in today's morning, and best wishes from my side. Thank you. If you have any questions, you can send it through chat or raise any hands or anything. I don't know what is the methodology which you envisage to follow in today's meetup. Thank you. Thank you, Ankita.
Thank you so much, sir, for sharing. Thank you.
Welcome you all to our meetup on data science and artificial intelligence in manufacturing. Today's manufacturing landscape is rapidly transforming thanks to the disruptive power of data science, artificial intelligence, and the industrial Internet of Things. These technologies are revolutionizing how businesses operate, optimize processes, and drive innovation.
Now I welcome Mr. Bhupesh Daheria, founder, MUNI Campus, AI Data Science thought leader and speaker, to start with the keynote.
Thank you, Ankita. Professor Ankita, and thank you, Professor Gangopadhyay, for setting up the context. And you have raised quite pertinent questions that will be wise that AI will take over everything, and still you require human intelligence, and you have given wonderful insight and examples that how Mercedes is still uses for premium cars, not artificial intelligence, but rely on more on the human intelligence. But all of us, we are aware that artificial intelligence, data science, industry 4.0 has become pervasive and ubiquitous. And yes, of course, they have got its own limitations, but they're driving a different level of customer experience, a different level of innovation. And that's the way forward. But yes, of course, we need to be much more cautious in terms of completely relying on these technologies. And of course, subsequently, I will also talk about a couple of challenges. And we do have experts with us, Avinash, Ravi, and they will be really throwing light on what are the real world challenges. So let me share my screen and start my brief presentation. So the idea of my talk is to set up the ground what Dr. Gangopadhyay tried doing it, and cover, say, 20,000 feet view about data science and AI in manufacturing. And here is my agenda. So I'll be talking about a brief landscape of manufacturing in India and around the world. What are the challenges, brief challenges? We'll touch upon what are the technologies which is fueling industry 4.0. We'll briefly see what data science and AI is all about, so that it will also give us some idea to that where we can really apply, not only limiting to what current use cases are. We'll also talk about some use cases of data science and AI in manufacturing and production. We'll talk about some implementation framework. We'll also talk about some skills and tools for the success. And at the end, we can really take up questions and answers, and we'll also briefly touch upon how Aegis is contributing in this field. So let's start our discussion. So manufacturing industry, production industry is one of the largest industries across the world. The global industry valued roughly around $13 trillion. To give you perspective, what this $13 trillion means, Indian economy stands roughly around $2.8 trillion. So you can understand, and India is among top 5 global economies. Increasing adoption of Industry 4.0 in manufacturing. Of course, Industry 4.0 started in Germany. Now it is going everywhere. Elon Musk, Gig Factory, AI Factory has completely adopted the Industry 4.0 concepts. India manufacturing sector currently contributes to roughly around 16% of the GDP, which government of India aspires to bring the contribution to roughly around 25%. And we should remember that India, once upon a time, was a leader into manufacturing at a global place. And our GDP contribution to the global economy was roughly around 20%, which is today's time is nearly somewhere around 3%. And we were, once upon a time, we were a leader into manufacturing. And 16th century, we were providing all kind of manufacturing goods across the world. And this was tamed down and by the Britishers' occupation, and of course the first industrial revolution which was fueled by Indian loot money. I would not like to dwell much on that part, but wanted to really touch upon that. Yes, although we were heavily criticized that we were lagging behind in manufacturing, but we were the leaders. I remember my optical telecom days. I spent my initial career in manufacturing in optical optical telecom, and we were manufacturing optical fiber. So I have been exposed to world-class manufacturing facilities, and in a real world, I have seen the challenges and the opportunity India had. And the kind of criticism we used to have this comment that when India can't really make a register properly, how India is going to really be leader in manufacturing. But our day has come, and now we are leading a big way in India world in terms of manufacturing. The world has also realized that they can't completely rely on China, and the world focus and our Indian government focus to make India as a world's largest manufacturing hub is into the action. And we hope to achieve, hopefully by 2030, become world's manufacturing hub. But there are a lot of caveats, and we need to really consider that in this whole process, we should not destroy our environment, just like China has done, because ways to improve, in West, they have the cost of manufacturing is high. They also want to protect their environment, and hence the dirty work of manufacturing they have shifted to China, and China became the world factory. But the cost China has paid is immense. They also took the dividend, but the cost on the nature they have paid heavily, and we need to be cautious on those parts. Now, India aims to reach 25% of GDP contribution by manufacturing by 2025 under the Make in India initiative. Initially, there were a lot of skepticism about Make in India initiative, but I'm glad it is really taking a momentum. The major sector which is under manufacturing are automotive, textile, chemical, pharmaceutical, food processing, electronics. To give a perspective what manufacturing is essentially converting a raw material into finished goods, or completely making some complex products like airline or a printer or a mobile phone or any other stuff. India employs roughly around 30 million people in manufacturing. September 22 manufacturing purchasing managers index, India stood roughly around 55. FDI inflow is growing, and India has also announced PLI for production of semiconductor and advanced chemicals, cell batteries to fuel EV revolution. And this is a wonderful initiative, and we believe that it is going to really attract billions of dollars of investment, and it will also generate millions of employment. That's a brief landscape. Let's also talk about what are the various components in manufacturing. So manufacturing starts right from the product design and development. We made a big mistake in terms of not designing in India, and we didn't invest a lot of money in designing. So most of the designing used to happen in overseas and Italy. A car we are designed over there. Still it does, but now, of late, India realized that we need to really invest a lot of money in design, and India started investing in design. That's one major component, whether you want to design a chip or whether you want to manufacture a car. First, you have to really design. Then you need to really think about the production planning, that how you're going to really produce that product. Then you need to really think about from where you will get the raw material, how you'll take care of the supply chain, right from procuring the raw material to your plant and shipping back the finished good from your plant to the end mile. It could be a shop or it could be a customer's premise, right? Then you have to really think about setting up a plant and machinery. And personally, I was involved in setting up a plant for PIGF cable in my first job. So you need to really find out the best machineries. You need to find out the plant location and then set up the plant. Then you need to think about the best of the manufacturing processes. You need to be careful about quality control and assurance. Japanese, at once upon a time, were known as one of the poorest quality of product, but over the years they have improved because of their ruthless quality control and assurance. And today they have become the global benchmark for their quality. Germans and Japanese. Then you need to really bring about automation and robotics to make modern plant. And Elon Musk has completely revolutionized the manufacturing and production of a car, which nobody has seen so far. He has changed the complete dynamics by building up a AI factory, gig factory, wherein majority of the work is done by the robots, giant robots, right? From not only lifting the cars, but also cutting the sheets, making the doors, fitting those doors into the plant. So majority of the work is done by those giant robots. Electronic manufacturing, the small robots are playing a major role. Maintenance and asset management, inventory management, warehousing, logistics and distribution. And logistics and distribution, we were taking it so granted, but COVID has shown how fragile this logistics supply chain is. And a single virus can really disrupt entire logistics supply chain. So that's one of the major component of manufacturing and production. And then continuous improvement, and the Japanese are the best to really show us the pathway. And now Chinese have also started improving their products. Chinese are also notorious about their bad quality of product, but over the years they have also adopted or copied the model what Japanese have done. India still has to really make its name at a global level. We don't have many good brands which we can really claim that yes, they are the global brands in manufacturing. And now, since the framework is already set, the government policies are in our favor, barring few policies. The huge investment is there. Now we have also become the quality conscious, not only the companies, but the customers. And customers, since they have been exposed to the world's best quality of the product, now they're also demanding. And since demand is coming, the Indian manufacturers have also leveled up because of the demand, because of the pressure which is coming from the customers. And now we can really see the kind of quality cars Indian manufacturers are making, and not only in terms of a design, but their performance. And drastically has improved in last, say, 5 years or 6 years, last decade. So these are the critical component of manufacturing. Why I spoke about these critical component, because then you can really think about where to really apply AI and data science or analytics or any other technology. Let's talk about what are the challenges so that we can really understand where to really apply AI and data science to improve efficiency or overcome these challenges. The power ability, the power conditions is pretty poor in India. Labor productivity is poor because of the supply chain, logistics, and because of the poor skilling. Typically in Western world, labor productivity is more than 50%. In China, roughly around the skilling in the skilled manpower in the Western world is more than 50% the skilled manpower is there, while the India's working population, hardly 5% of them, they have been properly trained and skilled. Intellectual property protection and enforcement is pretty poor here in India. And if you produce any product and somebody can really copy that. If we need to really go in a long run, we need to really provide a protection and incentive, and we can really make sure that the innovator can be incentivized until unless we don't have proper IP law protection and enforcement. Cost of fragmented transportation and logistics, because the whole logistic industry is fragmented. And not only in manufacturing, we have seen in agriculture, right? Millions and billions of produce are rotten because we don't have proper logistics and supply to even take those farm goods from farm to the end user. Tomatoes or chilies, and we hear these kind of news is that farmers produce those goods and they did not get the proper price, and They could not really get proper vehicles, so they have to really destroy the entire goods right there on the farm. So it's a pretty fragmented, pretty poor, and I think government alone cannot really do, but I'm glad that a lot of startup companies are coming in this area and really fix the problem. And since there is a problem, there is a challenge. This also offers a huge business opportunities. Hundreds of logistics and supply chain startups have come into this place, and of course powered by AI, and they are really doing amazing work. Just like a logistic now, and these companies, they're doing extremely good work. Increasing product complexity, because let's say mobile phone, if you see the earlier mobile phone, feature phone, and today's smartphone, the complexity level is extremely high. And for that, the kind of sophistication and the kind of investment you need to do on the machinery is growing exponentially. Quality control and assurance, we are not quite quality conscious, and that need to really come. Environment and sustainability concerns, these are not just havoc created by some NGOs. Of course, that politics we can't really deny, but at what cost we will produce something, we also need to really leave this environment for our generations. We can't really consume this environment for ourselves and create a product which die with cancer and other diseases. So we need to be very much conscious about building up sustainable and green factories, green products, which does not damage the environment. And eventually, we as a human being, we are a part of the environment. The nature of the earth is a living organism, and we need to really give a respect and be conscious about that. And I believe that these technology advancement can really certainly take care of that, or help in law enforcement agencies to monitor, let's say, for example, the factories which are running on Gangetic Plain or near Ganga. Ganga is heavily polluted, and government is trying very hard to really clean Ganga or Yamuna, but still they have failed. Because one of the major reasons these factories which are out there, they are releasing their waste material in Yamuna and Ganga or several other rivers. And there's no way that Pollution Control Board is able to really check. Because of two reasons. One, the corruption at a ground level. The second, they don't have any means to actually check if the waste material or hazardous chemical are being released in midnight. And the only way forward is essentially put sophisticated IoT network, drone technologies, satellite technologies, use computer visions and monitor that what kind of waste material are being released. So even while you're sleeping, even while ground level people are pressurized because of corruption or because of threat to their life, which is real in places like UP or Bihar, we can't really undermine that they're only corrupt, but they also have a threat to their life. I think technology at a centralized level can really monitor and help to penalize those who are not complying those laws. Workforce skill gap, this is a big challenge. And I think the AR, VR technology will really help in that way. And the government's initiative on Skill India, NSDC's initiative, they have set up like multiple industry sector councils. I think that's a good way forward. We are collaborating with various other countries to improve our skill quotient. These are the challenges, and I'm really hopeful the way things are moving in the last couple of years. I'm hopeful that we will certainly overcome these challenges. And these challenges are not only India. Some challenges are specific to India, but these challenges are across the world. So let's touch upon Industry 4.0. Industry 4.0, we can't deny, it's a reality, and slowly and gradually. So this notion started from Germany, now gone to Japan, US is adopting, India is slowly and gradually getting into that. China is aggressively adopting these. these are the couple of technologies which are actually laying the foundation of Industry 4.0. Industry 4.0 is a fundamental philosophy which uses the combination of technologies to make smart factories. Smart factories which behave like a living organism, right? Wherein the idea is not that you actually, if you have to redesign the product and then you actually buy the raw material and then you start placing those materials into assembly line and then you finally get the output product. Now, the smart factory notion backed upon Industry 4.0, even proposing that the final product has got its own intelligence. So the final product has its own embedded memory, which will decide that which assembly line or which machinery it is going to really go to get into the shape of that final product. And I'm sure that yes, we'll reach to that level. And the kind of way AI has exponentially gaining its own intelligence and power. In last 6 months and a year, we have seen various examples, and example, of course, like transformer technology backed GPT. I'm sure that yes, we'll be able to really reach to that level. But on ground level, what are those technologies which is fueling Industry 4.0? And the fundamental technology in industrial IoT. Industrial IoT will be is a way in which you will be collecting the data from machines. You will be collecting the data maybe from conveyor belts. You will be collecting the data from any kind of machinery. And then based on collection of the data, you will be taking the actions. And then you will be passing those actions to those actuators, which will subsequently take action. And actuators, let's say, for example, if the temperature is rising below a certain threshold level, the machine need to be stopped, right? So, so IoT IoT will really aggregate the data, and this IoT platform will push this data into big data analytics platform. This will put into data science platform. This will feed into the AI and ML and DL algorithms, which will become like a brain to take the actionable insight or corrective actions, and maybe related to waste management, maybe related to taking the proactive actions, or maybe related to predictive maintenance, right? Or maybe taking actions related to supply chain or any other stuff. Then the cyber physical system, this is another, it's not a technology, but it's a more of a philosophy, which is what it is doing. It is combining the data which is coming from the machines processes, right? So that you actually create a living organism of the entire production plant. And you can really intervene, and you can really take the sense what is actually happening on the ground, right? And this also forms a base for digital twins. And digital twins, it is being predicted that majority of the production facilities will in next 5 to 6 years will have the digital twins. And digital twin is basically what you're trying to really do. You're trying to really create the replica of the physical assets, and they could really include machineries, your systems, everything into a digital avatar, digital framework, wherein you don't have to actually physically visit the plant and check each machinery. But this digital twin is, let's presume that is a kind of a model of your live factory. And there you will be able to really see precisely what's happening on each machine, what is the temperature. So not going on individual machines and checking the PLC or SCADA systems, right? You're seeing the data at one consolidated level, that what's happening, what the temperature, what the pressure, right? What the performance, how much the production is happening on the ground level, right? So you will get the real pulse just like your human body. Then blockchain is working like blockchain will play a significant role in terms of really identifying to track if, let's say, product is there was some issue with your product. So the blockchain will be able to really keep the record and hash of right from the raw material to the production line, assembly line, from where what has happened. So let's say, for example, if some complaint happens, or let's say you produce a bad quality of product, you will be able to actually pinpoint where there were a problem, right? And whether the problem was with the raw material or not, and whether the raw material was coming from India or maybe in Kenya or Africa or whatever. Robotics and automation. For long, robots are being deployed, right? And automation is happening because you want to really bring in efficiency. Modern factories, modern plants, you'll find less and less adoption of the human being. It is done by the automation and robots. 3D printing is playing a major role in terms of critical components. You can actually print those critical components, so you don't have to really wait for months to really demand from the supplier, right? And you can really cut down your downtime. Cloud has become, instead of rather having your own generator kind of scenario, or rather than having your own data warehouse, you can really keep on pushing that data on the cloud. And the kind of capabilities cloud providers, whether GCP or AWS or Microsoft Azure has pushed and brought on the table, and even the local cloud providers, NetMagic and other players. Not only it is providing the storage, but it is also providing a lot of other layers which is related to the blockchain, IoT, or analytics or data science, right? So you don't have to really build in everything from the ground up, right? So you can not only you store the data, but you can actually take a lot of massaging and a lot of analytics on top of that, right? And this can really fasten up your digital transformation journey. Or let's say traditionally, if you really take 20 years or 5 years with cloud platforms, you can really reach your digital transformation journey to as fast as 6 months to a year span, which is unprecedented. Now, while we spoke about, say, various other technologies, let's spend 2 minutes time to go deeper into what is AI and data science, so that this will fuel your imagination that where actually you can apply data science and AI in terms of those challenges and various key components of production or manufacturing industry, which we spoke about. So AI is more of a philosophy of bringing machines closer to the human being. It is a way, technological way through which you actually try to mimic the human behavior. My take on AI, there's nothing artificial about that. It's basically aggregation of human intelligence at a scale. To give you my point, let's say when you're using the Google Map, you trust Google Map more than the God while you drive on the Mumbai street. And Google Map is nothing but it's a basically real-time data inputs provided or intelligence provided by individual beings, millions of live humans, to this Google Map platform, which is actually giving the real insight that don't drive on road, take this road, you have got the less traffic. While on other side, let's take example of ChatGPT. ChatGPT, when the country was got independence, you had Dr. Ambedkar, who was perhaps one of the most literate and educated person on India. Now today, perhaps the ChatGPT is the most knowledgeable and literate person on this planet and more knowledgeable. You ask any question and it is able to really give you the answer with a fairly reasonable accuracy. And why? Not that it is intelligent, because the data, mass amount of the data is being fed. Almost all possible books, almost any kind of textual data which is available on the internet or Wikipedia is fed into, say, ChatGPT. And one of the indicator of the intelligence is your ability to graph the data, process it, and then give the final, say, output, intelligent outputs. So ChatGPT is also basically, it has aggregated the human intelligence and then giving you the output to take the right decision at a scale. When I'm talking about a scale, not one human being, but millions and billions of the people are able to really take the that. And it's so amazing today that you don't require that extraordinary power, godlike power, but this AI is giving you godlike power. So let's imagine that you have the Saraswati Devi sitting beside you and telling you everything which you want to really ask. So AI brings the human intelligence into any system or any factory or any technology you're building, right? Data science, on the other hand, also forms the base for the artificial intelligence. It's basically traditional analytics applied on the large volume of the data and the data which is coming from the multiple sources. It could be text data, it could be images, it could be video or any other thing. Traditional analytics used to, or statistical analysis used to do analysis based on the structured data. Wherein today you are generating data which is not only structured, unstructured data, and it has got the numeric data, it has got the text data, it has got the log data, it has got the images and video, and you cannot simply analyze that large volume of the data with statistical methods or traditional analytics. You need a lot of AI tools, which is like computer vision to analyze videos or images. You analyze NLP to really analyze the customer's responses, right? So you actually apply analytics on the large of the volume of the data, variety of the data, to drive the sense out of the data, to take the meaningful insight so that you can really take the action. To give you example, you can really analyze a tire manufacturer can analyze the data from multiple points, and then they can really improve their supply chain, right? Or let's say example on some example which all of us can really relate. Let's say example, Facebook analyzes your text data, images data, video data, everything what you're posting. And based on that, it is able to really suggest what kind of ad they should really serve you, or what kind of further content they should really provide you. Likewise, YouTube as well. So while we understood briefly about what is AI and data science, let's see a couple of applications of data science and AI. So when I used to really work in my first job in Optal in 95, we used to do periodic maintenance, which is kind of a preventive maintenance. So we decide one day, and then we actually go deeper into the machines and we try to do the maintenance, anticipating that someday this will really break down. But now what will happen that you have to really shut down the machine for the whole Sunday or maybe Saturday. This is kind of a luxury. So while you want to really improve the efficiency of your plant, you want to really cut down the downtime, you can't really have this luxury. So what you do, you put in the sensors, IoT sensors, and collect the data about vibration, temperature, pressure, right? And then you also check the historical data when the machine went down, or how many product this machine manufactures, and then it starts breaking down. You collect all those data, and based on that data, you're able to really predict that, yes, now this is the time that this machine requires a maintenance, and let's do the maintenance, and let's not wait for the breakdown. And majority of the companies are providing this predictive maintenance, and this is one of the major use case of AI and data science in manufacturing or production. Quality control and inspection switch on. We'll talk about how they are actually using computer vision to find out the defects in the products on assembly line. We used to do the manual inspection of cable or fiber which is coming out. Of course, machines were there, but not as efficient. Today's computer vision technology, backed up by the neural network, deep learning network, surpasses the human accuracy, and they can actually detect very finer point in terms of if some scratch is there on, or there's some bad painting which is done on the cast door, right? Or some product you're making and some crack on that product. Computer vision can actually analyze based on the images you put on camera on top of the production line, and then you capture the data in real time. It can really give you the idea. Supply chain optimization, this is a big use case. Based on the customer data, past data, competitors data, actually you can do the demand forecast that, and based on that you can actually subsequently make your production plant and your inventory plant. Energy efficiency improvement or energy saving is one of the major area where data science and AI is being used. So traditionally, when you really lit a plant, this is one of the use case. When you lit a plant, you rely more on the you rely essentially some electrical contractors provides you those inside, but not necessarily those are pretty efficient or those are very scientific. Now, based on the data collected by the sensors, you can actually plan. Let's example, you're putting the AC, but based on the weather conditions, you can actually offset your temperature. This temperature can automatically be controlled. And now you're saying that weather is pretty erratic. So even the summer days, you will find the temperature goes down because there is a rain. So you don't have to really maintain the temperature of 22 degrees or 18 degrees. Based on the external condition, you can automatically regulate the temperature, and you can save a huge amount of the money. AI data science is primarily used in reducing the cost of manufacturing, increasing the production efficiency. It helps you in minimizing the waste. Now, generative technologies backed up by the GAIN is helping to really give you theoretically infinite number of design possibilities. And based on the multiple inputs about the cost, about the customer preferences, customer age, and this can really help you to come up with designs which customers are likely to really like, and it will also save your time and it can really improve your revenue. I'm sure we have other speakers, Avinash, he will talk about, or Ravi will talk about the real-time use cases. Implementation, how do you really implement data science and AI? First, you have to formulate the problem, collect the data, then develop the model, then evaluate the model, and then deploy that model and integrate that model into some app or a web, or and see the continuous performance and give the feedback. And machine learning has got this amazing capability of working on the continuous learning loop. Key challenges in adoption of data science and AI is number one, quality of the data, availability of the data. You have old legacy systems like SCADA systems, PLC systems, right? And taking the data from all those systems is extremely difficult. So either you replace those legacy systems or deploy new IoT-based SCADA systems or advanced PLC systems, but sometimes it is not cost effective. So you have to really build a lot of workarounds to take the data from those and bring that data to a centralized place so that you can really take action. And that requires a huge domain level expertise. And that comes to the second or third point, which is a skilled workforce. So not only those who are doing the production, but those who are actually deploying this data science, they also need to really have some domain understanding on the ground. At the same time, they also need to really have in-depth theoretical knowledge, and at the same time, the application knowledge, because you can't just borrow the system from the West. You have to really modify as per the Indian conditions. While talking in these conferences about use cases is pretty easy, but actually deploying it in the real world is extremely, extremely difficult. It's not easy. And manufacturing in production is one of the toughest industry to actually deploy these use cases. Resistance in changes, initial high investment, and resistance in changes is a human being, right? So top guy says, "अरे चल तो रहा है अभी इसकी क्या जरूरत है?" Right? ऐसे कैसे होगा? मशीन कैसे, ये कैमरा कैसे डिटेक्ट कर लेगा? मैं तो ज्यादा कर लेता हूँ, मेरा ऑपरेटर अच्छे से कर लेता है. So we need to really overcome those and slowly and gradually we are coming to the pressure and we are realizing that we need to really go for this. Security concerns, if you really create a completely cyber physical system, digital twins, and you digitize everything, you need to have very strong security concerns. Otherwise, any hacker can really hack your digital twins or cyber physical systems and create havoc or put any kind of malware while you're manufacturing any electronic devices or a mobile phone or maybe switch or a laptop or a computer. So it's a pretty scary and you need to really take cognizance of those security concerns. Model explainability, because most of the use cases, typically, let's for example, inspection, you're using deep learning. These are neural networks and they're not pretty logical. And the explainability of these models are extremely difficult. They're like a black box. So how do you really trust something which you can't really explain? So we need to really work upon explainability of those models, regulatory compliances. Now, here are a couple of startups which I have listed down. You'll hear from LiveSense and SwitchOn. And there are other startups which are doing extremely good job on deploying the multiple use cases which I spoke about. So LiveSense is working primarily on offering the secure environment in manufacturing, and while SwitchOn is offering solutions on live inspection using the computer vision. What Aegis is doing, Aegis is providing very high quality of education in terms of area of exponential technology, which is AI, ML, deep learning, analytics, IoT, Industry 4.0. We are offering consulting and we are providing executive education. So our idea is to provide a knowledge shield to Indian manufacturing, Indian IT, Indian software, Indian industries by providing this high quality education, applied knowledge, so that you can actually deploy these use cases over there. I teach the use cases in machine learning, AI, deep learning, and I've been teaching this use case course for last almost 8 years. We also organize this Aegis Graham Bell Awards, Aegis Graham Bell Award Talent Hunt, and there we try to really identify young talent from across the country, across the world, and we provide them 100% scholarship so that they can gain this very powerful knowledge and take these use cases in the real world. And to mention, our students have built pothole detection, they have built Kojo project for identifying missing children, they have built product to identify damage on a car in a real time for insurance claim and other stuff. So at Aegis, we are doing amazingly good job in terms of really teaching and building up data products as well. With this note, I express my thanks to all of you for patience hearing. And if you have any question, I can take 1 or 2 questions. If we have a time or okay, thank you so much, everybody. I would be glad to connect you offline. You can write me over email or you can connect me over LinkedIn. Over to you, Professor Ankita.
Yes, sir. Thank you for letting us know all the different challenges, applications, technologies in AI and data science related to manufacturing domain. Thank you so much, sir. Now I welcome Mr. Avnish Kumar, founder and CEO, LiveSense, to take away the session. Welcome.
Avnish, my heartily welcome to you. Thank you so much for accepting invitation. And I'm really glad. I feel so happy. You're doing amazing work, amazing work. Keep it up. Thank you so much. I will not
thank you. And thank you, BPC. And you have really set the ground for me to present now. So I'll take it from there, where Bhupesh has talked about it, and let me just share my thing. And specifically today, I'm going to cover the sustainability because that's what the challenge for the industry is. And as we talked about, like a lot of the fundamental challenges of manufacturing is not going to go away. And unless we get to a digitalization, which is comprehensively able to capture data, we are not going to get into the sustainable manufacturing anytime sooner. And that's what is the need for it. We can develop various hardware products, but the challenge is all hardware still is creating the silos of islands in manufacturing. To solve this problem, what we have done is we have created a comprehensive AI platform, which is called GreenOps, and that is able to capture data in a plug and play manner from the various silos, which is not just the equipment data, it is the data which is all about the process engineering, process data, and it is replicable in multiple industries very easily with the plug and play AI models. That's what we are trying to do. And I'll talk about a few of the use cases, but first I will try to recap and give you the challenges which Bhupesh talked about in the past session. So Levinsense, we are actually focusing on three things. The first is how do we make the manufacturing operations efficient? We deliver value because the value is very important given the kind of stiff competition, and specifically when we are trying to get into a competition from getting from China and Taiwan and various other countries like Vietnam is also coming up in manufacturing. And the third most importance is going to be on the carbon emission, because carbon emission is going to wipe away the entire bottom line of the company if we are not addressing it today. That's what we are trying to do. And this is what is our objective is. We are based out of Bangalore. We are we are doing this product completely as Make in India, though we have sales offices in London and US. This is what the carbon tragedy is today, just to give that. 36 gigatons of carbon dioxide is specifically coming out of the most of the process industry, which is called as hard to abate industry, be it iron and steel, which is contributing to more than 24%, almost 1/4 of that emission is coming from iron and steel. And then the aluminum, which is, even though it is 6%, the amount of emission which comes out of aluminum is almost like 11 metric tons of carbon emission for every metric ton of the aluminum that is being produced today. That is the kind of carbon intensity involved here. The petrochemical is definitely the industry which is fully oil-based, and cement, which is our infrastructure backbone, which is primarily dependent on coal. And we have been working with one of the leading cement company as well as the research center in India, where we are trying to help transition to alternate fuel, specifically the liquid fuel, which is the waste material coming from the chemical. So that's what we are trying. These are some of the things, but the key challenge is energy is a holistic analysis, holistic problem. It is not just about the utilities energy, it's about the fuel or the fuel consumption you're doing. It is also the process emission, which contributes to carbon monoxide. It leads to SOx and NOx. And that is what the issue today is. And why it is so challenging? Because today, as I said, like most of the challenges is because of the multiple different systems deployed in the manufacturing ecosystem over a period of time, starting from level 0 to level 4, like OT-IT system is anyway separated, but even within the OT systems, we have maintenance systems separate, we have production systems is separate, quality and LIMS is separate, R&D and process engineering is separate. So the challenge is, unless you have data at a holistic level, you can't do the analysis. And this is what the continuous and batch process industry challenges is today. Decision making, specifically for improving efficiency, profitability, and energy balancing, requires you to get a holistic understanding of all the data, which requires you to understand energy data, process data, the understanding of the combustion and chemical reaction. Today, because of this, companies are already having a hit onto their bottom line. On top of it, they are also having top line losses, which is almost amounting to $200 billion globally in terms of just the chemical industries alone. And today, the cost of abatement of the typically for the carbon is going to be $500 billion for industry in chemical side. Even if I take one company on average in chemical industry, it is going to be $2.5 billion of cost, which is going to come in by 2030 if we don't take action. So that's the kind of seriousness of the problem is today. Hard to abate industry decarbonization is a big challenge. And the other thing which we are also very closely watching, because we definitely are looking into the various alternate fuels to capacitor banks, green hydrogen, and all new technology. But the challenge is there is still hardware-based technologies. It will take at least up to 2030 to come in certain limited mass production, and then to full-fledged mass production will only happen by 2050. And that is the challenge. And again, the green hydrogen has its own challenge because it's a new technology. We are still not sure the actual effectiveness in terms of the input to output electricity generation, the sources, because it will have the sources of water, the quality of water. So all this is putting us in a situation that you need to find an alternative mechanism which can work in parallel with the mainstream hardware technologies. And eventually both these technologies has to combine together. And that's what is our effort has been. GreenOps has been evolved and innovated to work as a parallel stream and then merge with the green technologies eventually when they come to a shape where they can be mass production. And this is what the market analysis is. Scope 1, 2, and 3 are the major challenges today, whether it is oil and gas, natural gas, steel, cement, and aluminum. You can see that today they are the one which is contributing significant amount of scope 1 and 2, as scope 3 is still more onto the is an area where we need to evolve. And that's what we are trying to do, because this is where the data is still not even visible today from an end-to-end supply chain perspective. So what we are trying to do, this is what we are trying to do, that how we can use scientific-based techniques. So AI/ML becomes very critical in this kind of application, because using science-based technologies combined with AI/ML, and we are looking at complete cradle to grave kind of situation. So when the materials come to a factory, for example, when the materials come to a aluminum smelting plant, whether it all the way from bauxite mining to the alumina, we have to track the carbon intensity of the material. We need to look into the mix of the material, the impurities in that. That is what is upstream of the scope 3. The scope 1 and 2 is what happens within the plant, specifically what kind of energy you are consuming, what sources of energy you are consuming in scope 1. The scope 2 is all about your production process, the whole, it could be entire the smelting process or chemical reactions, which is again can be optimized very well with the AI/ML technologies and the use of add-on IoT where the sensor data is not available. Finally, the scope 3 is all about the vehicles which finally carry the material, the finished good to the last mile, to then last mile to shipyard, and it goes to the ships, because that is where the challenge still remains. But we are trying to focus on right now at least the last mile and look at the holistic approach of a scope 1 and 2. But again, this is a long-term evolution. Eventually, the data acquisition is the key here. And you can see this an example today. Petrochemical has got such a very complex approach. And we are looking at what we can do it, at least the scope 1, 2, and part of a scope 3. And we can still bring at least 20 to 25% of the carbon reduction as of today, before jumping into the next level where we can look into at least reaching up to 40 to 50% of carbon reduction through the software, AI, and IoT combination of technologies. And that's what we are trying to innovate. This is what is our product is all about. One of the key things is the ability to acquire data from all the silos, be it maintenance system, production system, or the utility systems. We are capturing every possible data wherever it is there, bring to a real-time analysis. And here again, we are looking into in-process deviations. We are looking at fluctuations in the data, because those are very critical, because this contributes a significant portion of your the noise in the data. And until you don't tackle the noise, then your reliability or the overall outcome of the AI based systems will not be very high. And that is one of the key failure points we have seen in past. And that is where we have built soft sensors to augment the hardware sensors, where instrument deviations set in over a period of time. We are looking at fluctuation, disturbance index, and then we are also trying to evolve the closed loop based AI system that can look into further correction or auto correction kind of system. And then we apply the process AI model, which can be built based on the historical data, the domain knowledge, and most importantly, the first principles based method. Because today, if you are not marrying the first principle with the AI modeling approach, then again, there is a challenge of delivering outcome in a manufacturing kind of setup. Finally, digital twins is also playing a very important role, because it plays the role of simulation where the data is not enough. Suppose in certain plant, we are only having an access to data for 1 month or 2 months. and you need a 1 year of data, it is only approaches to start using this simulation. So it's all like multiple combination of technology brought into one system. And that is what we call it as an integrated approach and system integrated. And this is what the success for any product, whether it is our product or anybody trying to do this, has to look into it. AI has to look into a comprehensive manner, combining with the domain knowledge of industry, first principles, simulation, and IoT kind of thing. And that's what is the bigger challenges. You can see how we are doing today. We are capturing energy data, waste data, materials intensity data, combustion data. All this is being acquired through the multiple sources, whether it is plant system, whether it is environmental data, whether it is the data sitting in some ERP system or CRM system. We acquire everything. We do a baselining, because without doing a baselining, you can't even have that further improvisation on the carbon or at least reduction on the carbon models. So we start with the disturbance index, soft sensors, reduce the noise, make the data more reliable before we feed into our AI models. And then we do this simulation wherever the data is not enough, and we give this scenario-based approach so that all this decision support is in real time, and we can get an actionable outcome across a scope 1 and 2 and even 3 also. And finally, the reporting can be used by the operator, not only for the purpose of reporting, but even they can start reducing the carbon emission. And that's what we are doing it. So this is what the look and feel of the complexity which we are doing today. You can see this is a petrochemical plant, how we are collecting data from the various sources and applying a complex mathematical to first principle and the AI models in one combination. And we are able to deliver a real-time recommendation engine or system for the operator to simplify the entire complexity which is behind it. This is what the applicability of AI, and this is something which is what we are trying to do by leveraging the AI and software technologies to deliver this kind of outcome. I'll show you a few examples how it is done. This is how it works today. Our real-time engine is able to capture 300K real-time sensor data monitoring. We are processing almost 50 terabytes of data in just one plant to identify the minor level of deviations and where that can cause your cost of energy can go up and high, specifically in petrochemical industry. And it's all being done today in a configurable way. It can be deployed on premises if the customer is not willing for hosting it in the cloud, and it can be done in hybrid, and it can be all automatically. The real-time data can be acquired, automated tags can be generated, which is all green energy tags, which can be used through our KPIs, configurable KPIs, and then we start delivering the result within few weeks. That is what we have started doing it. When we started, we were taking almost 6 months to do that. Today, we have come to a production grade scaling where within weeks, if data is all available and acquired, within weeks, we are there from start to end. And this is what the power of AI is all about. And these are a few of the use cases which we have already delivered it in oil and gas, metals, petrochemical, utility segment. Also a few of them. This is one of the use case in a oil and gas segment. You can see how we are giving the entire recommendation. It is a delayed coker unit where you can see the pre-recommendation values versus the post-recommendation, where the coke reduction we have achieved to the range of close to 2.5%. And we are giving the NOx emission reduction, CO2, CO, and overall emission reduction. We have done almost by close to 5% from an overall GHG intensity perspective on almost a month-on-month basis. And this is another one where the smelting operations, you can see the real time, we are able to control the dynamics of the pot temperature balance, and we are able to reduce the chemical wastages, which is excess ALF3, and we are able to offer a prediction in real time with the ability to configure the addition of ALF3. We have optimized to the level that they can control and maintain the pot balance in the right manner. And that has reduced almost 7% of GHG intensity here. This is another mining O&M company, because the same approach with a configurable AI we have done. This is where we have been able to help not only bring the E part of it, but the safety part of it. You can see the safety of the people working in and around the mining vehicles, and then reducing the fuel cost of the mining, including looking into the hauling operations, synchronization between the dump truck to the shovel. All these are being done today. In fact, we are also trying to see how we can work with the telecom operator by leveraging 5G in a closed network kind of environment and bring a synchronization between the various equipments moving and non-moving, and bring a holistic approach towards the energy balancing. So these are the few things. This is another automotive company where we are doing this whole paint shop energy optimization, which is a high consumption energy today. So these are the few things. Why we are doing it? Because deep decarbonization requires, fundamentally is based on an AI platform. As I said, the unified AI platform is very important, and everything requires AI, from real-time process optimization to advanced process analysis, and bringing the whole holistic AI-based energy balancing is all fundamentally we have built on the first principles, mathematical models and AI models today. And this is what is our roadmap. But this is what today we are doing. This we are able to look at the entire holistic journey from furnaces, charge gas compressor, heat exchanger, boiler to calciners, kilns, and fire heaters with a scalable AI modeling. So what is very important is when you develop an AI platform, AI model, how do you make it scalable? How you can start utilizing it? And one of the learning is also you can't use the open source AI, which is what has been happening in past in manufacturing. You have to look at the level of integration with the domain knowledge and the customization. Until that is not there, it is very difficult to achieve this kind of scalability. So this is what we have been doing, and this is some of our success. We have recently also won one of the awards, specifically in Electrama, and this is what is our carbon emission dashboard. You can see across cement, asphalt, boiler, we are giving a real-time dashboard of how much of a scope 1 and 2 reduction is happening across these plants. In certain cases, if it's only scope 1, then we are giving a scope 1, and all the carbon tracing from end-to-end perspective we are giving. So this is one of its kind of dashboard completely enabled by our AI technology. So that's pretty much is all about. And finally, I'll be opening up for the questions if there is any. But I would like to thank again Aegis School for because we have been leveraging the interns as well as some of the freshers we have hired, and they have done tremendously good job in the past. And I would like to thank again for Aegis for all the collaboration and support, for recognizing our innovation, as well as helping us with the very good talented AI engineers from their institution. So thanks once again. I'll take up any questions if this is there for another couple of minutes.
Thank you, Anish sir. Thank you for letting us know the different challenges you have solved, like the different solutions that you have given in the manufacturing domain using AI. It was really a wonderful session. Thank you.
Thank you. Thank you. Thank you very much.
Thank you. So now I welcome Mr. Ravi Ranjan Prasad, Principal Product Developer, BMC Software. So he's also a proud alumni of Aegis. So over to you, sir.
Yeah. So yeah, welcome everybody. I did my ePGP in 2015, and then from there I started my career as data scientist. So Bhupesh sir, Abhijit sir, and Avinash, they all talked about what is going on in manufacturing using AI and data science, right? So I have just, I'll just touch upon few things here. What is manufacturing analytics, little bit of that, then you can ask me any questions that you have, right? So I've not made very judgy PPT or something. I'll just go through the basics of that. So if somebody wants to take up his career in that, so he can think of how he can go. So let me share my screen if I can. Can I share my screen? I think I'm not seeing that sharing.
Yes, sir, you'll be able to share.
Yeah, got it. So, yeah. Yeah. So as you guys, I told about myself that I'm Ravi Ranjan Prasad and I am ePGP 2015 batch, like, so maybe a starting batch of Aegis in data science. Right. So I'll be talking about manufacturing analytics and how it enhances productivity and operations in manufacturing. So with two stories, right? So and to just get the context, right? So how data science can be used uh, in manufacturing, right? So the first one is the story where manufacturing company is struggling with quality control. Right? They are not able to find the root cause analysis why this happened, right? But when the data analyst collected production data and then analyzed it, so he noticed what used to happen is the issue used to it was because the routine maintenance was done on Fridays, right? By getting that pattern, right? So it he came to know that equipment shutdown was causing the quality issue, right? So there was routine maintenance on Fridays. Because of that, equipments were shut down on that day, and because of that, there was quality issue, right? So you see that how these things are connected, right? Now they understood that what was the root cause, and they rescheduled the maintenance work, right, to different time, and the quality issue disappeared. So now you see that they are trying left and right, trying to do everything, but they are not able to find the root cause. But just by analyzing the data, they found the reason and they solved the problem, right? So I'll talk about the second story about the production and operations, right? So the manufacturing company wanted to produce, to its target. So they were not able to uh, keep their target because of some reason that they were not able to understand. Right. Again, the manufacturing analytics team was they did the analysis of the data, right, and they found that there was one machine which was causing the bottleneck in the production line. And because of that machine, because that was old, that was always breaking down, uh, the whole production line was getting affected because of that, and that was hampering production. So they recommended to the company to replace the machine with a newer and faster machine. So the company did that, and the production increased, and their target was met, or even it was done, even more, right? So now the company realized the importance of using data to make informed decision in their operations. So I just wanted to tell these two stories to bring the context why we need manufacturing analytics. Okay. So now I'll talk about what is manufacturing analytics, right? So manufacturing analytics is use of data analytics and machine learning techniques to extract insight and make data-driven decisions in manufacturing industry. Any other industry, we have plethora of data, right? So that we can use ML techniques, and then we can get useful insight, and we can make decisions based on those insights. Okay. So I'll talk briefly about few of the business cases already Rupesh sir has discussed about. Rupesh sir used to take the business use cases classes, right? So I'll start with supply chain. Supply chain is one of the very important part of manufacturing industry, right? So in that there are many business cases, but there are four which are predominantly used. One is demand forecasting, right? So using the historical data, we can do time series forecasting for what will be the demand of any product, or and then inventory optimization with historical data. We can see that how much inventory is required to from factory to the market, right? So how much inventory to keep, how much to send. And then also we can use historical data for supplier performance, right? And we can also use this for early warning system, right? So systems, right? So when the threshold is breached or something happens, right? So we have to warn the system, right? So for that, we can use the historical data, right? And we can use that for creating the alert wherever it is required. So that the next business case is regarding the product quality, right? So in product quality, we can do real-time quality monitoring. We can find the root cause of any problem that is coming. We can also test the reliability based on the historical data we have. We can also check the warranty, right? So by warranty, what I mean is suppose for any product that you are getting warranty, right? And what is in use by the other customers, right? So we can also with that we can see how the product quality can be increased. Okay. So the other business cases are field service and support, right? So again, inventory management comes into that, then supplier performance and transportation analytics. So transportation analytics is also, very much required in manufacturing industry, where we get the raw materials from outside and we send our finished product to the market, right? So if we do proper transportation analytics, then we can, save a lot of money into that. So one use case, I just want to tell you about Indian Railways. When I was working with one of the goods, so we used to one rake, right? So one rake is of 40 right? It is fully loaded, but while coming back, we did not do anything, right? So it used to come empty, right? So for that, then we did some analytics and we found and we made a system so that while it is coming back, that time also we can book, right? We can also book for station, right? So by doing all those analytics, we generated a lot of money for railways. Then there is using the data, right? Using the data of the manufacturing company, we can create an efficient factory, right? So we can also check the real-time equipments and process monitoring, right? So process monitoring is very much important in manufacturing. Not only in manufacturing, it is everywhere. Maybe in data center or whatever you think of, right? So real-time equipment monitoring and process monitoring can be done with AI or data science, right? So that is very much important, and the process capability enhancement can be also done, right? So we can also optimize the maintenance and overall equipment effectiveness and factory productivity. So these things, earlier used to be done manually. Now with automation, these things are done very effectively. So there are many benefits of manufacturing analytics, right? So few of them are we have real-time visibility of the operations, how it is going, right? So is there any bottleneck or something is going wrong or everything is going right, right? So we can do all those monitoring using manufacturing analytics, right? So we can also do predictive maintenance and quality control with manufacturing analytics. We can also optimize production and supply chain management, right? So as we have seen the use cases, right? So we can optimize the production and supply chain management, the cost reduction and improved profitability, right? So once you do all these things, right, so obviously your cost will be reduced, right, and you will get more productivity. Okay, so I'll just touch upon the manufacturing analytics tools, right? So what does that mean? So there are many manufacturing analytics tools in the market, right? So actually, manufacturing analytics tools are the software applications which are designed to for manufacturers to gain insight into their operations and processes by analyzing their production data, right? So what those tools do is they do statistical analysis, they do machine learning and data visualization. These are the things that they do, and with that they come up with the insights. They come up with the historical how it happened, what it happened, and all those things they analyze, right? So it also identifies the trend or pattern in the data and provides the actionable insight for optimizing production processes and improving overall efficiency. So these are few manufacturing analytics tools, right? So one is SAS Factory Miner, then we have SAP Manufacturing Execution, Oracle Digital Supply Chain is there, that is for maintaining supply chain processes, and Siemens MindSphere is also there. That is very nice manufacturing analytics tool. So you people can also go and search for this analytics tool, and then get your hands dirty with these, and you can see that these are very nice manufacturing tools. If you know these tools, it will be very easy for you to this is one video that I have taken for digital factory. So how it works, I'll just run. It is for 2 minutes. So please let me know if you are able to hear.
It's not audible. You'll have to do stop sharing. Share it once again. There you'll have an option. Share with sound.
Yeah, sorry.
Yeah.
I thought that I have done it. Oh, sorry for that. It is asking for the password, so I think I'll not be able to do so. You can. Okay, so I just wanted to talk about what is digital factory. So digital factory is where we use data of the system, right, of the manufacturing system, and then we use everything from from starting from getting the raw material to the finished product, right, and everything is done digitally, right? So that is what I just wanted to show you guys. So if you have any question, you can ask me. I'll be happy answering those. So yeah, one thing I didn't wanted to discuss, right? So as Abhijit sir told, right, so about Mercedes. So I work in Mercedes, and I have seen their manufacturing unit, right? So what happens is the cars like A class or B class, they're prepared in mass, right? So for making in mass, they are using KUKA robots and other things, right? But when it comes for exclusiveness, right, so they do it themselves. That is the fact for crafting the making the watches also, right? So when you see that this is handmade watch, right? So the in Swiss people, they make watches uh, which comes for 25,000 CHF or more, right? So they are making it themselves without using any of the precision equipment. So uh, just I resonate what Avijit sir was telling, right? So we should be skeptical, but where we can use machine learning or data science is where we have machine learning or data science comes beyond our common sense, right? But it will not be uh, taking up the human intelligence. So between the human intelligence and the common sense comes AI. Thank you very much. If you have any question, you can ask. I will stop sharing.
Thank you, Ravi sir, for sharing your experience. It was wonderful. Thank you.
Thank you, ma'am. I thought that many questions will be coming up, so I talked about only for 12-13 minutes.
So we'll have discussion in the panel discussion, sir.
Okay, fine.
Yeah.
Welcome you all to our meetup on data science and artificial intelligence in manufacturing. Today's manufacturing landscape is rapidly transforming, thanks to the disruptive power of data science, artificial intelligence, and the industrial Internet of Things. These technologies are revolutionizing how businesses operate, optimize processes, and drive innovation.
Now I request Bhupesh Dharia sir to start with the panel discussion.
Good morning again. Thank you, Professor Ankita. So now we'll be starting our panel discussion on opportunities and challenges in AI and data science in manufacturing. So we have our esteemed speakers. So Professor Ankita is here. I would like to invite Ravi again. Please switch on your video. Aniruddha Banerjee, if you're there, please switch on your video. Avnishji, please switch on your video. Avnishji, you're there? Oh, Aniruddha, looks like we started early this panel discussion. The time was 12 noon. So Avnishji, Dr. Gangopadhyay, all these three will be joining at 12. So the time for panel discussion was 12 noon. I think we started early. So let's have 15-minute conversation among ourselves, Ravi, Professor Ankita, before these three prominent speakers join for the panel. So formally we'll start the panel at 12 noon. But so Ravi, since you started your journey in this data science and you have also worked in HP, Mercedes-Benz, right? So although the topic is about AI data science applications in manufacturing, but I'm sure I could really see there are a lot of candidates, those who have joined, and they may be curious to really know that how they can start their career in data science. What are the practical steps they can take? What kind of skills and competencies you require, right? So I am taking a divergence from our original topic so that we can really utilize this 15-minute time before these speakers join. Allow me to take this freedom.
Yes.
Ravi,
So,
would you like to really respond?
yes, sir. So, when we, study, right? So we think that we'll just jump into getting into data science and we become data scientists, right? So that is not the truth. So there are different parts of data science that we should start with, and gradually will converge as a data scientist. So we have data analytics, we have ML engineering, then we have data engineering. So these are different parts from where we can start, right? So if we like analysis of the data, so and we have business background, then we can go for business analytics. So if we have good background of database or ETL, so we can go for the programming languages and algorithms. We can go for machine learning. But gradually we'll come to know all about everything, data engineering, then business analytics or data analytics and ML engineering, and knowing all those, we can become a data scientist. So it is, data science is not a role; it is a journey.
Right.
So
Yeah, people say that you don't come and declare that I have become a scientist. Okay,
Yeah.
it is a journey that you started walking on.
Yeah,
Right,
so after doing my EPGP, right, so I also had the same thinking, right? I already had 12, 13 years of experience that time, and I thought that I become a data scientist. But it took for me a couple of years, and then again I wanted to dig in more into that. Now I'm doing PhD in machine learning. So it is a journey. So we have to start from one part of that. So we have to make one part very strong. Maybe data engineering part or data analysis part or ML engineering part, and then get into the data science world, and then gradually you take it up.
Okay, wonderful, wonderful. So fundamentally, you say that there are three components, which is one, domain knowledge, then the math, stats, linear algebra, calculus part, right? And you can put ML in that as well. And then the third part is tons of IT tools, which would be Python, Scala, Hadoop, Spark, right? Tableau, and tons of tools are there, right? TensorFlow. Now, how important in your journey was mathematics, statistics, linear algebra? Because while we were studying these concepts in our schools, high school, and even during our graduation, we were taught mechanically, and nobody has actually explained us what is the use of these mathematics. So how difficult was your journey in terms of understanding this? One, how important it is on the both side on conceptual understanding building, and of course in the real world.
Yeah, so it is very important. So one thing, I'm not just marketing it, but I'm telling that the statistics teacher in Aegis was very nice. He taught us, the nitty-gritties of statistics that we had forgotten after +2, and he also talked about how that statistics is used in the real life, right? So we know what is mean, right? But we hardly realize that everything tends to converge towards mean, and that's why we use mean for when we try to do imputation of data, right? So when we don't have data for somewhere, then we go for taking the mean of that, right? So the idea behind that is the whole world is converging towards the mean. We did not know this. We just know that take all the values and divide by the number of values, we'll get the average. So in that sense, not only that, so mathematics also, right? So we knew what is differentiation, integration, and how we can find the gradient, right? But doing the data science, we knew that what is the use of finding the gradient descent and all those things. So it is very important. If we don't know these things and we just know a few of the lines of the codes, right? Maybe for naive use cases, we'll be able to get the good results. But when the use cases are critical or where money is involved, right? So we cannot just go with any of the things. We have to understand what is inside that. So knowing mathematics, statistics, and also the domain knowledge, these are very important, right? So I would suggest people, I have seen many people saying that you don't need to know mathematics, you don't need to know statistics. No, it is to some level it is correct, but if you really want to do some production level, and you want to make products, right, production level products, or you want to work on the things where some money is involved in prediction of those things, right? So we have to know these things very deeply. So try to learn the tools as well as these concepts. So conceptual and practical knowledge both are required.
No, you rightly said. I had a panel discussion in Bangalore, and this panel discussion was about career in data science and AI. And I kind of taken aback when one very senior data scientist tried to really say that you don't actually require mathematics to become a data scientist. Generally, I don't
So,
tend to really counter.
so
I
that
actually countered that person. I said, no,
yeah,
you're
but
misleading people.
Who is called the father of AI, Andrew Ng. He, for selling
Right.
his products, he tells that mathematics is not required. But when he teaches in his college, right, so he teaches only mathematics.
Right. So Andrew, so if you hear Jeffrey Hinton, right, you'll realize although the neural network is not quite logical, but neural networks build upon all the mathematical concepts, right, from linear algebra to calculus and everything. And we rightly say that mathematics is the language of God, right? So
Yeah, true.
that's the language you can really decode the mind of the God or nature. Normal distribution, I don't know how, but it completely represents the real world, right? And hugely applied. So if there is a God exists, perhaps he understands not Hindi or English, but the language of maths.
Yeah,
And
true.
anyway, so I think we have Dr. Gangopadhyay over here. Aniruddha has also joined. Aniruddha, can you please switch on your webcam? Aniruddha, you can hear me?
Hello. Hi.
Yes, Aniruddha, we can hear you.
Yes. Yes. Hi.
Yeah, can you switch on your video?
Yes. Yes. A very good morning to
wonderful.
all of you. I hope that you
Good
can see me
morning.
and hear me all right.
Yes. We can hear you pretty loud and clear. Welcome to this panel discussion. So while we were waiting for you, I was chatting Ravi on his experience, on his skills and other stuff. So let me formally start this panel discussion. So welcome everybody, welcome all the speakers for this panel discussion on AI and data science in manufacturing, opportunities and challenges. I'm Bhupesh Jaharia. I will be moderating this panel. And we have pretty esteemed guests, Dr. Gangopadhyay, Ravi, Aniruddha, who have built a switch on, right? So these are the real practitioners. We have Professor Ankita, and Avinash will also be joining pretty soon. So how we'll start, I would like all of you to really give 1 or 2 minutes of your initial thoughts on this topic. At the same time, also, you'd like to really talk about your background, what you're doing, what your work is, right? And from there, we can really start our conversation. So let's start with you, Aniruddha.
Sure. Very good morning to all of you, and thank you so much for the introduction. So I'm Anirudh. I'm one of the founders at SwitchOn. I look after business development and strategy for North America and India at SwitchOn, which are our two primary markets. We automate quality inspection for manufacturing. So with the use of AI and computer vision, we basically check products as they get manufactured at a very, very high speed in state-of-the-art manufacturing lines in Fortune 100, Fortune 500 customers. We identify defects in those products and reject those products automatically, right? In doing this, we help our customers do a 100% quality check for products as high speed as about 10 parts per second. And we help them reduce their quality costs by 30 to 50%. We have worked very, very deeply, in terms of implementing this AI in the manufacturing industry. And, as the talk goes on, would love to share my experiences on the same. Thank you so much for inviting me.
Wonderful, wonderful, Anid. What's your initial thoughts on this challenges in manufacturing and opportunities?
Yeah,
in
absolutely. So I think talking from the opportunity side, I think as a lot of you may have seen that, supply chains globally in a lot of products are getting moved into India. And, that is because my view is that India is at a right point where enough infrastructure, capability, and intent is being seen by global brands such that these manufacturing units can actually produce their top-of-the-line products, right? As customers become more and more quality conscious, I think that, more and more automation and more, quality checks will, of course, be required to scale and stabilize such manufacturing lines. But on a macro perspective, there's a very welcome trend. If you saw that even about a decade or even 5 to 8 years back, most of the supply chains were, kind of from a manufacturing perspective, concentrated on China and so on, right? But it's on a very welcome note that it's being kind of moved into India in a lot of cases, electronics, consumer goods, etc., etc. From a challenge side, I think that manufacturing in India still is a combination of legacy and state-of-the-art, right? So there's a lot of different kinds of manufacturing processes, manufacturing plants, and each of them have SOPs, right? Coupled with the fact that we are not, as in general, as a population, good with SOP-driven processes and so on, right? So, that would need a cultural change as well as a bunch of upskilling to be able to manufacture products of global standards, right? So that's something of a challenge that I see. And here, of course, technology in general can really help, both in ensuring that SOPs are being followed, as well as in ensuring that the quality, of the products are according to global standards. So yeah, this is what I believe. Yeah.
No, thank you so much for invoking these challenging thoughts, and we'll park it over here. I'll come back to you and touch upon those points further. Dr. Gangopadhyay, you have seen as a policymaker, as an academician, and you have seen from where India was and today where India aspires to move. What are your thoughts on global level and what is happening in India? Do we have the future of becoming the hub for manufacturing? Your thoughts, sir, or anything? Sir, you are mute. Sir, you're on mute.
Probably nobody wants me to be unmute. So
we all want you to be unmute, sir. We would like to hear you.
No. It's a very good way of asking questions, and it's very. I'm happy to learn from Mr. Banerjee also. It's a wonderful opportunity. I have seen, I think, unlike you, I have seen the history. I don't know the current situation. I think I have seen almost all manufacturing industry only. I was not knowing that there could be any other industry other than manufacturing. Now I have since you are talking on perspective of international domain, I'm really sick of getting feedback about. I like to focus on India primarily, because the people all over the world start creeping about us. You see, our SOPs are so bad. I think right now, one of the chief manufacturer, I think they are now, and they are one of the plant is in India. So I think we are very poor in terms of documentations and really meeting the criteria. So they all abuse us, and it's really abusive that we don't follow any standardized practices. Now this is this is pertaining to the standard operating procedure which has to be done in any manufacturing industry. Say for example, I think if I talk about any manufacturing plant, I think the way it is, I think I have come to an era where manufacturing of two-wheelers, I think we were most dependent on two-wheelers. The manufacturing of majority of two-wheelers were so bad, and therefore Bajaj became the king, because they have some way their manufacturing plants were standardized. And that has actually made us to wait for 15 years for getting a product of theirs. So we are very lacking. Now, it is in our ecosystem, it is in our culture. And when you talk about artificial intelligence, I think it is very appropriate at some point of time. It used to fascinate me. The more robotization, the more better products we get. And I think I'm talking about a lower form of artificial intelligence applications. Now it is totally different, because I don't know if I am not able to enforce that. Say, if you talk about his development of manufacturing sector in anywhere in the world, say it has started from a long assembly line to a modular, cellular assembly line. The primary interested was that it will give us some amount of precision in terms of product quality and improvement of the procedures. Now, out of frustration, they started breaking the long chain of manufacturing. I think that was one of the preconditions in terms of automatizing the process. Say, for example, today, if I don't want to talk about a particular industry, because we are all aware why we go for particular products and why we avoid others. It is primarily because the way it is handled, even if for medicine also. I think probably if I give an option, since I don't have money, I will offer for an international medicine rather than going for Indian. Although they are as good as, and many people worldwide they say they're better than any part of the world. Now I feel that here I think AI can really help us in terms of streamlining in manufacturing processes. But the process is, again, the person interface will be there. Now, how you can integrate it, it is, according to me, it is one of the most challenging. I have not seen across the sector, be it a service sector, be it a manufacturing sector, everywhere, the process standardization is a major issue. Even if I have a process, but the moment it comes to some human processes, immediately it starts getting disturbed. It is very annoying, it is very disturbing. Now, what is to be done, I don't know. And as a result, I think we need urgently to augment the artificial intelligence intervention in other places. Because when I get from somebody who is very close and near to me, that although he was born here, he is working there, now immediately start accusing us as if our country is absolutely better, worst, in terms of writing up the processes. Now, I don't know. And they say that the moment we say, they take it very casually. But I strongly believe that in a country, in any processing, I think human interface ought to be there, and it will be there. How to streamline that, how to change that culture is a major anxiety for us. Otherwise, it's all very nice to talk about artificial intelligence and streamlining this one. Say, for example, you see, the question is that if I apply the mechanization or automation, the deviation will be very marginal, very small amount. I think it's a statistical concept because the larger the population, the error will be minimum. But how to eliminate that? And I think this is a challenge. And here probably artificial intelligence can come in a very long way in terms of helping us out of the error. And if I can do that, I think that will be the wide applications of artificial intelligence. Another thing is that we always talk about in the major concern which is often raised, if I have artificial intelligence or automation in any form, in any format, I think if it is then the problem will be there will be job loss. It's a human face. I think that is not a criteria when it comes to, according to me, whether we are losing job or gaining job, it's not a criteria for making a bad product. And these are the few thinking which I'd like to say to the practitioners. I'm not a practitioner. I'm a paper tiger, if at all. And I think as a result, my experiences are very, say the type of error which we commit in terms of processing anything. I think even in standardizations, even if I talk about educational space also, same thing is happening. I think it is not being processed. I'm not a part. We are culturally, we have to unlearn many things which we have learned. And it is not a problem of human being. It's a problem of our own old way of working. But this artificial intelligence will really force us to adopt a new or emerging methods of work space. Thank you. I think I'm there, so I can definitely answer anything.
Thank you, sir. Thank you so much for such a thought-provoking, and I really like your statement. A very strong statement that the manufacturing is not for just generating the employment, and to employ people, you can't really compromise on the quality of the product, right? So whether humans are making or whether machines are making, as a consumer, we want good products and for which we are willing to pay the money. And specifically in high critical areas like health or maybe critical infrastructure like a refinery or say any power plant, you can't really have the bad product because you just wanted to employ the large population and they are the inferior quality of the stuff. And I think government is also getting out of this mindset. But still, sir, I'm prompted to really ask you because you have handled with the labor laws and you have worked with the unions and you have seen the ground level on the manufacturing plants across the country. You have educated the top management and you have worked over there. What is the ground level reality? Don't you think that the labor laws are still the bottleneck in India? And I've seen my first plant where I worked, it is just shut down because of the labor laws and the unions and everything. Otherwise, this company would have become the Jetty or Huawei of the world. What's your thoughts, sir?
I think I won't agree with the way of which you used to think. I think I used to think this way, but now labor people are more sensitive,
right?
Because they also understand ultimately they have to have a job employment, and it is not the volume; it is the quality employment which they all are looking for, and therefore I don't think that should be. It does not mean that we will go for. Say, for example, if I today talk about the processes, even I had an occasion of visiting many of the European and other plants also. Say for Germany, I have seen their auto plants, automobile plants. I think they have a very strong union. People are scared, management or everybody is scared of them. But the way they comply with the process requirement. Say, for example, think about Japan. See, the way they comply with the process requirement, with all said and done, I'm an Indian, but I feel thrice in purchasing an Indian produced car or any manufactured, which has no relationship with this one. And therefore, at any point of time, Toyota, Honda is always in, because I can't afford Mercedes and others. That's all. That's definitely a problem. But the question is that you have to understand that the moment you say, people have been have warned me that if you use these process-oriented cars, then probably products, then subsequently you will be able to find it very difficult to adjust. But we are what we are. And actually, I'm also talking sense only when I am speaking to you. But when I behave, I'm totally nonsense. Actually, we have a very big cognitive gap. Now, artificial intelligence does not care for these cognitive gaps. We are very sensible, Bhupeshi and my colleagues. But when it comes to, and the students, those who are attending this, but when it comes to doing, we are totally different. And I feel that this can be bridged by artificial intelligence module in terms of product manufacturing. And we have to, now we cannot shy away from manufacturing. We have to do that. Look at it, see, the China's manufacturing strength is probably part of it. My experience with the Chinese industry, I have seen this one. And I think I fully agree with it. They are almost, so Japanese are almost like driven by artificial intelligence. Now the Chinese have also started getting themselves driven by that. And thereby they are winning. They are winning our confidence also. Thank you. But I'm happy to disagree. If you can disagree with me, I'll be very happy. I don't feel shy of
No, I would like to be stand corrected. I think my experience was like almost 27 years back, right? But I could really see what you're talking about because Tata bought over the Range Rover, right? And they actually brought in a huge transformation without cutting the manpower. The Jaguar, so Jaguar was absolutely horrible quality of a car. People used to say that buy two cars, one you can drive and the other one you can keep it in the garage for repair. But and strict regulatory, strict union control environment, Tata could really brought in or improve the quality. I think it is not only the unions, perhaps maybe the compliance in the processes and the sensitivity of individual being. Yes, you're right that we can really talk a lot of rational things in such forums, or we can really discuss rationality. But when it comes to the actions, sometimes we become irrational. And I think the crowd mentality, which is there on the ground of these unions in a crowd, they actually behave absolutely different. And we have seen how the whole state has collapsed, just like Madhya Pradesh or West Bengal. They have fallen prey for these unions and combined irrational thinking of the group called unions. But that's a different topic. We'll talk about that. And you're right that yes, as these giga plants and AI is coming slowly and gradually, they'll replace most of the human beings. You wanted to say something?
Since I lived in XLRI and Jamshedpur, I have seen very closely the Tatas. Actually, it's a part of the Tata colony also. I have seen them and visited the telco or Tata Steel, and they are our very good neighbors also. Now, I have seen that the union was very proactive in them. They don't have, they negotiate with them, and it can be. Union is not a trade anywhere. And now it is more because they have also realized they are on ground, more grounded than what you were. I conducted a study in which I feel that it is our anticipation that this implementation of any technological advances will be objected by them. They don't object. They are now very educated. They are better educated than many of the management staff, and they have the competency of becoming good manager also. They do manage. Thank you.
Thank you, sir. Thank you, sir. Thank you so much. So Ravi, sir touched upon Mercedes-Benz. You also worked in Mercedes-Benz, right? So would you like to really throw upon some use cases? First of all, why Mercedes-Benz hired a data scientist, and what role you were playing? If you can really share something, some use cases which is publicly available, not confidential. Would you like to really throw some light?
Yeah, I thought to discuss about this, so but I did not have this forum, right? But you rightly asked me this question. So in Mercedes or any other automotive domain, right? So we need data scientists. So I was not into the DAS, that is autopilot thing, right? So that is mostly used in most of the automobile system, right, where they need data scientists. but I was working in powertrain, right? So in that we used to, get the data from the cars, ECUs, right? So we have, more than 250 electronic ECUs, right? So then, and they collect the data from the car, right? So what my work was there is to, collect the data from the car and then find that at which time any of the car's part will be broken, right? So we had like we were in R&D, so we had R&D cars that we used to send for test cars for rides, right? So we had different terrains and different places we used to do that, right? So before sending that car, earlier it was like, the mechanic will check the whole car whether this is good or not, because the car will go for 1 month and it will run on different types of roads, right? So my project that I worked in was any of the part will be damaged, right? So if it is going to be damaged in next 2-3 months, so better replace that. So many times it was found that test drive, but that test in the middle of the test drive, when it is going from Germany to Spain, it broke down. So and then after using that thing in our test cars, it was also used in customer cars. So when you go to the workshop, right? So for maybe routine maintenance, right? So they will tell you that these all are the parts which will be broken after a few months. So if you want, you can get it replaced. If you agree with us, agree with our system, or if you don't, then you can come back when you want, right? So when it started, right, many people, they did not we told that your brakes will be bad in 2 months. They told, oh God, what they're they're just trying to reap money from us, right? But after 2 months it happened, right? Between 2 or 3 months. Much in Mercedes, I think other also doing that. So to some, that was my project that I was working on, but there are different departments where we need AI engineers or data scientists, right? And most primarily they are in ADAS system, right? So when, if like they are using because earlier it was all hard, different AI methods, right? So if somebody wants to go into automobile, right? So 90% of the work of AI is done in ADAS system, and 10% in other places. But AI is everywhere in the whole automotive domain.
Yes, kind of like has become quite ubiquitous, right? You can't really get away with that. I remember while I was working in my production plant, we used to manufacture optical fiber and optical fiber cables, and for cable inspection, sometimes the operators used to manually inspect the cable. And it was pretty sophisticated plant. It was this plant was established by Fujitsu in collaboration with Fujitsu. Complete AC plant, very sophisticated plant. And I'm amazed to really see, Anirudh, what your company Switch-On is doing. Is actually taking up the computer vision concept which we teach in our class to the real world in plant production line, wherein you're able to really use that to detect the defects in the product. I would like to really understand from you much deeper level how you guys are doing and what benefits customer is drawing, what are the practical issues you are facing in terms of deploying your systems, right? Or whatever you wish to really speak. Anirudh, over to you.
Sure. Thanks for that. So, I'll talk about a little bit of the impact that we are making first, and then I'll go into the technology, right? So,
Sure.
So as I had mentioned earlier, we basically automate quality inspection for the manufacturing industry, right? So presently, most of this is being done in a manual manner, right? So if we talk about automotive, it's basically 100% to 150% manual inspection that happens both pre-dispatch as well as inside the lines. And if you talk about consumer goods, it's basically a random inspection. They inspect 1 in 5,000, 1 in 6,000 products, right? Because of which, what ends up happening is that even in the most advanced manufacturing line, the typical rejection ratio is about 3 to 4%, right? Which means that 3 to 4 in 100 products is a defective product, right? Which essentially goes out from the manufacturer to the wholesaler, to the retailer, to the end customer, right? To a point where even if you go currently to your nearest supermarket, you will be able to see products that have some kind of artwork defect, or the printing not being legible, etc., right? This is what we at Switch On are essentially automating, right? So we are adding the capability for our customers to do an automated inspection, and for very, very high speed lines, we work with as high as about 1200 plus parts per minute kind of lines, right?
Wow.
And we do an AI inspection of entire products for that, right? The benefits of these are kind of threefold. One, obviously, we do 100% inspection that enables our customers to meet their 100% compliance requirements, right? Which are government-related compliances, right? The second thing is that we ensure that our customers are able to eliminate defects by the end of their line, right? So no defected product ends up in the hands of the customers, and which is whenever you see, especially in both consumer goods as well as automotive, there's a lot of attribution of a defected product to the brand, right? So if you're using, for example, a Unilever soap or an ITC product, you essentially are straight away interacting with the brand to a certain degree on a regular basis, right? So we ensure that that interaction goes well 100% of the time. And the third thing is we essentially, and as mentioned earlier, right, that we essentially remove the repetitive process of picking up a product, figuring out a defect, and putting it in a good or a bad bin, right? Which is a very, very slow, very error-prone, very manual-driven process, right? From there, inspectors, using our AI systems, are able to go to the next level where they are able to actually figure out why defects are happening, generate different kind of quality reports from there and so on, all on their own, right? So we are, to a large extent, augmenting the skill set that they have to, instead of doing a manual repetitive, job, enabling them to use an AI platform to do their day-to-day work a lot more efficiently, right? And in the process, obviously cutting down 30 to 50% of the quality costs that a typical brand incurs. So that is kind of, from, an overall perspective, the value we add to our customers. From a technology perspective, I think one of the major things that AI has been struggling with is the images or the large number of training sets that typically is required to train a deep learning model, right? And, I must say that in most supervised platforms, it's very complex to train it in a proper manner. It's very regular to see AI platforms being deployed and taking 6 to 8 months to stabilize, right? So from the time that a user purchases a product, imagine you being the user, right? Imagine waiting for 8 months to get or see any value. It's a very large amount of time, right? And that's, I think, one of the very big challenges that AI is facing right now, right? And I think at Switch On, how we have enabled a faster, value and ROI is by using a very different a newer kind of AI called unsupervised AI, right? Where we are able to train deep learning models with as less as about 200 images and still reach 99.9% plus kind of accuracies, right? And this is what enables our customers to see value within days of the deployment, right? But this is actually a very big challenge in AI, right? And this is further, I would say, exacerbated by the fact that most of the manufacturers manufacture hundreds of SKUs, hundreds of different kinds of products, and so on, right? And training deep learning models classically has not been possible, for this large kind of, data set, right, without taking months and even sometimes years to stabilize this. So yeah, I think that is from a technology perspective. From our side, we have innovated a lot on the modeling itself, the data platform that enables that, the platform that enables our customers to, in most of the cases, train the systems themselves, and so on and so forth, right? But we at Switch On, the way we are trying to solve this is to give this in the hands of our users, right? And largely democratize the training and the inspection itself.
Well, that's quite incredible, right? So I'm really impressed that you're able to train your models with just simple 200 images. Are you using transfer learning, or are you're doing some different techniques?
So we do not use transfer learning as such. We use a different kind of modeling itself, right? Which is though based out of ResNet-esque backbones, right? But yeah, I think we do use some of the concepts of transfer learning in terms of in terms of the intelligence of the product being embedded into base models, right? So yeah.
Yeah, another problem you may be having, because you may not be having the similar industry to really work upon. So what is your experience here in India? Where are your customers, based in the Western world or here in India?
So we have customers both in India and in the US, right? And I think one of the good parts about our customers is that since we work with very large enterprises, right? Most of them have a fair degree of standardization in their manufacturing lines, and due to which, it's been slightly easier for us to build such models, right? The flip side of this is that the minimum acceptance criteria for them is 99.9% plus kind of accuracies, right? Which is like table stakes kind of, right? However, in this, I must say that we've seen a lot of support from the plant teams, right? And I do, I remember hearing sometime back that actually the people at the ground level, at the factory level, are trying to upskill themselves. And this is something that we have actually firsthand interacted with, right? We've received a bunch of extremely good feedback and really a lot of enthusiasm in using our platform, right, to upskill themselves, right, rather than going into the path of, no, this will come in the way of our day-to-day work and stuff like that, right? So I think that has been something that's been actually far better than we had in fact expected when we had started, right? So yeah, I think
no, of course, because they save their life, right? Because they have to manually do that tedious and painful job. I remember doing that job. It's quite painful. So any technology will be welcome. Those who can really say automate their tasks until doesn't really replace them from the plant. That's a far fetch. So Professor Ankita, since you're teaching, right, and what Aegis is doing in terms of really training students to come to this level wherein actually they can build this deep learning models, machine learning models, not only for the manufacturing, but other industries as well.
Right. Good afternoon, everyone. So I'm Ankita, professor at Aegis School of Data Science. So I am there in Aegis since 5 years. I have around 5+ years of experience. So coming to, I don't have any specific domain knowledge as such, but you can tell me, like, if you're telling me data science, I teach for people who are coming from all domains. Right. So like we have executive batch, right? So people who are actually working. So the thing is, there is a gap in the skills. So that gap, what they're finding when they're actually working in their domain. So that is where I help them out. And not only in manufacturing industry, as well as it is coming from all the industry. Like some of them are working into finance, some are into healthcare, some are into manufacturing. So they take up their problems, and whatever they are facing, they'll share it with us. And after we are able to teach them all the machine learning models. So after that, they are able to actually build up the model, and it is really helping them out in their career. So that is where we are helping them out. And again, not only this is one part, that is the executive students, where actually they are working and where they are finding that gap in their skills, and they are able to come here, learn, and they are able to explore in their industry. That is one part. The other part is freshers, wherein we teach full-time batch, right? And when I'm saying freshers, we not only have, like when you say data science and all, it is people ask like, are you from IT? So it is not so. So people from all the background, even like BCom and people who have done BA. I have seen my students becoming data analyst, data scientist, right? And whatever 1 year of time that they have, they are really hardworking, so that they are able to really perform well, and they are able to do well in their industry, whichever industry they have joined. And most of them, they call and tell us that this is how it is, this is how it is. And I have also learned a lot from my students. It is not because I was into teaching. So after coming here, maybe practical experiences and whatever models they are able to build in our institute. And once they are, some of them for the capstone project, so what they do is they take the real-time data, what they have, and they build and they showcase their talent. That is, it is really helping us out also. And this is how we help students and executive batches to explore in the field of AI and data science.
Wonderful. Thank you so much. So your fundamental knowledge, they can really, data science and AI is industry agnostic. They can really apply these learnings in any industry, whether it's an automobile or airline or manufacturing or telecom, IT, software, healthcare, fintech, almost in every industry. Of course, each industry has got its complexity wherein the domain understanding comes, and I'm sure these domain experts really help. And if they really do a couple of projects, they can really pick up those domains lingo.
Right.
And it's a long journey.
Right now, even Avnish Kumar, he has also told that most of our students who are working with them, that has helped his company also. So we feel proud about that.
Thank you. Thank you. Thank you, Sankita. So now coming on the second phase of our panel discussion, right? So as Dr. Gangopadhyay was talking about, of course, he put up 2 points that yes, we can't really completely rely on artificial intelligence. But at the same time, other place, we pointed out that yes, as a customer, we deserve to be good product, whether it is created by human being or AI. We really don't care. While Aniruddha also really mentioned, and I was really surprised to hear his claim that 1200 units are being produced at such a fast speed in real time. They're able to do the 100% inspection, which was actually kind of impossible for human being to do that inspection, no matter how intelligent and how brainy you are. While India is suffered with traditional legacy infrastructure, I'm glad that most of the companies, those who have a global presence, they have brought in the best of the technology in plant and manufacturing here in India. But still there are large segment, which is SME segment, and certain companies which has brought the old infrastructure and machinery plants from the Western world. That is still struggling. Now, so there is a hope there. We see that yes, some Indian companies are using AI, and On the other extreme side, there is small manufacturers. They don't have the capacity, they don't have the money, and they don't have the knowledge as well. There is still struggling and doing those manual work, and still the manpower is not trained, and that's the ground reality. And you can find within the 50 kilometers or 100 kilometers radius of Mumbai, you don't have to really go pretty far. Under these scenarios, how India, which is aspiring to become the world's hub for the manufacturing, and China, which is started almost 30-40 years back, their ambition, and we are quite ambitious to reach to that level in the next 7 years. So what are your take, all of you, the question open to everybody, and that how we'll be able to really overcome those challenges and reach to that ambitious target with AI or without AI, or your take, open to anybody whosoever want to really respond. Sir, Anirudh, Ravi.
We want Gangopadhyay sir to start.
Yeah. Sir, your microphone is mute.
Yes, I have not done any criminal crime. But it's
you
very
have the vastest experience.
when
among all of
Mr.
us.
Banerjee talks about this huge speed, I have
Right.
happened to be, I don't want to name that company. I happen to be in an assignment with them, and as an internal person, but an outsider. And they work at a very tremendous speed. But I think error is very high. They do error management. But you see, the type of things the management was trying to explain it to me, that they have two types of market. One is the so-called Indian or like India markets. I don't want to name other countries because I have a place to name my own country. But they say that whatever is defect, we send it to them. So this is a very interesting way of looking at the things. You should cut down your. You see, machines are working at so high speed. Huge amount of production loss will be there because they can't reclaim that material. Now, my question is that the days of bipolarity of the countries will soon be different. So, for example, now nobody can on earth, nobody can say that we can supply India without any much of process control. To other countries, we have to become a process control. No, it's not true for South America, North America, Europe, India. I think everybody has become now process driven, and they are also interested. The customers will reject because they have a readily other market. So at this point of time, since you are actively involved in artificial intelligence and these technological tools, I think you all should be helping in terms of restructuring manufacturing technology sector, because manufacturing is a key sector for any economy, whether it talks about GDP or anyone. And therefore, this thing has to be ensured, and it is possible. Now, for that, what we require capability of the your coder or the coding. See, for example, with the huge bad type of coding, I think the coders which are available, I think you can really make a machine learning program which will be effectively controlling such deviations. So we have to be very, very precise. So it has to. Say, for example, it is not an option. I think probably the course on artificial intelligence should be given. Say, for example, today, it is very surprisingly, when I was in IIT, mechanical engineering students never used to think about computers. See, they used to always avoid computer science department. I don't know why. And actually, this was on my mind frame. We had a mainframe. I think you can imagine what was the looking at it. I used to get looking at their output also used to get scared. We never had PC those days, but now the things are manageable, and probably all professionals should be equally at least basic IT literacy should be there, and respect for coding, as if coding is something which I am guilty of that. I feel that coding is not for me. No, no. Everything I am also coding. I think everything what I do are being coded to me. I also make the codings, and thereby I learn. Na? And machine learning is not an abstract concept. I also learn by that way. I know how to drive in Indian roads. How? I think it is just not possible, those who come from outside, they get so scared. But we are not scared because we know every unpredictability. But this is not the process. We need to be process driven also. I think probably I fail miserably in any learning driver learning test. But I drive. I have nobody taught me driving. Somehow I got a license, and I think getting license is not a very difficult thing in India. I think all these things, I have seen that if you really want to improve, I think we have to have an optimism in terms of adhering to this development. And if we develop, then it will be very easy. Say, look at the processing. Data processing is not done properly. How many mistakes even after TCS is administering our immigration or the passport issuing, still they are making. Why? Because the same people are not being sensitized to that. I think they should not. I have never seen any mistake in passports. Also, it has reduced. Earlier, it was totally, really, if I look at my old passports, the way they documented it was, now it has been totally improved. And that has happened because it has become IT technology enabled. But it's a good, I am very hopeful. I'm not a pessimist. I'm optimist. I'm so much optimist that I cross both way traffic roads without looking at any end. I love to see that it grows. And I think AI is absolutely implemented. You see, I had a Government of India project, visual inspectors. You wouldn't believe, say, we have a designation called visual inspector, many of the defense production unit. And I was really, once I have a look at their entire data set, I found that they get so troubled because they cannot, any visual inspector can't work in 8-hour shift. Get fatigued. Na? And I think probably, and if it is an aided, say for example, today, if I talk about robotic surgery, I think how many cases the robotic surgeon's experience, he does nothing. But all of a sudden, the machine gets stuck. No. Thereby, there comes his intervention. So artificial intelligence is not a substitute for intelligence. There should be close monitoring. If I have an automatic landing system, I think pilot is not getting oblivion, but he's working. And if he gets it in auto mode, most of our pilots are averse to that also. It's very interesting. Why they should averse? They should monitor. They should, and then take over, because they have all controls to take over the things also. And this is my submission to all of you. I think probably you are all working together, I'm sure, because that is what Mr. Banerjee's company is doing. But it has to be done more sincerely and more seriously. And if it is done, then it will be helpful to everyone. Error elimination is a very big problem. As a teacher, I have always experienced a problem whenever anything comes for evaluation to me. Because if it comes to for evaluation, be it a PhD thesis or be it a paper, I think I really have it. Because finding out some error in anything requires a very deep insight. If I have now I'm using IT softwares to run so that I can immediately get it. Visually, it is not possible, or probably for a human being, it is not possible. So tributes are to detect that. Now we have, say for example, we have a piracy software. It really immediately gives me the total, how much copy I have made. I'm used to it. I think we are criminals actually. So, but this artificial intelligence is almost eliminating. Say for example, my professors could not identify anything, but now I am able to. So thanks to all the IT enableness, which has made us absolutely safe. Thank you.
Yes, sir. I just want to add a few things here. Right. So Just to add into sir, right? So when we talk about AI, right? So we should not take AI in isolation, right? So we have to take AI, automation, and all those things, related things together, right? So and AI should not be used like a human being. It should be used as recommender system. So we should take a recommendation from AI and then we should take the decision. We should not let AI take all the decisions. Right, and as I told earlier also, so AI is between common sense and human intelligence. It cannot surpass. It has surpassed already the common sense of human being, but it cannot surpass the human intelligence. So human intelligence will always be required. Will always require a human to look after the things. But AI can be 100% used as recommender system.
Very true.
Wonderful, wonderful. Aniruddha, over to you.
Yeah, absolutely. So I'd take a slightly different view here, right? So, there are certain things that AI is spectacularly good at, right? Even better than humans, by the way, right? And there are certain things that AI is not very good at, right? So what I would say is that basically from a usage of AI perspective, right? Just to give some real examples, right? So we are identifying defects that are about 100 micron, right, in products that move at nearly 1200 parts per minute, right? This is superhuman capability, right? At that speed, and you have to see it to believe it. The products are not visible, basically, from a human eye perspective, right? And what AI is spectacularly good at is doing different kinds of pattern matching, right, on such kind of product to identify defects, right? Humans are also not good at achieving 99.9% plus repeatability, right? Because to achieve that, you need a certain degree of, mechanization in your brain that humans are just not very good at, right? So I think where I would kind of differ is that there are certain things in which AI should be taking the final call, right? Especially in things like, repetitive processes where, for example, identifying defects in products, right? Where humans should not be involved, right? And at a 1200 parts per minute, just to let you know, it is not possible for humans to intervene, right? I mean, before you even see the alarm beeper, right, the product is already gone, right? So you better have an automated process of rejecting the defected products, right? There are certain places where AI is not very good at yet, which is, for example, creative pursuits, right? Where, for example, while large language models presently are kind of trying to bring in a lot of difference, right? But there are obviously a lot of limitations to how how creative such models can get, at least in the present state, right? So I would say that in those kind of cases, definitely, the humans should be taking the final call and maybe reviewing the final draft that AI has written for them, right? So that's kind of what my view is. In terms of, I think there's also a conflated conversation happening on, for example, how much can AI replace humans, right? So I would again take a slightly different view here. I think humans are not going to be replaced by AI. Humans are going to be replaced by humans who know how to use AI, right? So, if you don't know how to use AI, if you don't know how it works, then you are definitely going to get replaced in the next few years, right? But I have actually seen personally, really executive level operators using our systems, right? And this is an out and out AI system, right? So I can see that with enough intention and with enough infrastructure, it can be done. The question really presently is that, do you want to do it or not? And I would argue that you must, if you want to stay relevant in the modern world.
Exactly.
Now, very well said, Aniruddha. On a lighter point, I guess AI's understanding about the context is limited. So inside the products which are being rejected, So which product Indian should consume and which product should be export quality? वो बोलते हैं ना, कह रहे सर ये एक्सपोर्ट क्वालिटी मटेरियल है, आम एक्सपोर्ट क्वालिटी क्या आपको दे रहे हैं, नहीं तो धुआ ही जाता है. So
Yep.
this kind of
Yep.
contextual understanding I will not be
Yeah.
able to bring. But you rightly said, older days, like people
Yeah.
said that computer will replace a human being, but eventually those who actually started using computers, they improve their earning potentials. They increase their longevity of their career.
Yep.
And Dr. Gangopadhyay also pointed out one of the fundamental flaws in our education system, and not only Indian education system across the world, this fundamental flaws, which is basically silo systems of education, demarcation. And I think most of us, we are product of that silo system of learning. So you have mechanical engineering, you have civil engineering, you have electrical engineering, where in electrical engineering is mother of computer science and electronics, right, or IT. So we created a silo and we said, okay, mechanical engineers, you will not study coding. Electrical engineers, you don't need to study coding. And that mindset of still we really face, still we have a conversation with several candidates every month, right? And we are trying to really break. A mechanical engineer comes and says, sir, coding nahi pata hai. Ye to AI, data science is for computer science guys, what I am going to really do. And we have to really explain them hard that, as Gangopadhyay sir said, everybody does coding, and AI is basically replica of human mind, neural network. So everybody can really do, and thanks to this new education policy, NEP, wherein they are trying to really push Python even to the 5th grade students. So this silo model of education need to really change. And while if we really see Industry 4.0, the modern, say, living organism of any smart AI factory, the mechanical part, the processes and the systems and the human being, they all are interconnected, right? And that's what we are trying to really achieve. And hence these silo models of education system also need to be broken upon. And regulatory bodies like AICT or UGC need to really take a cognizance of that. They're still making a mistake that they have again created a BTech in data science and BTech in AI, right? And there is the politics because you want to increase the number of seats, which is a bitter truth. So you again keep on adding. So you're again creating a distance within the computer science guys and the data science. And they forget that that the best data scientist is basically statistics and mathematics guys they become rather than only purely computer science guys, right? So they need to really work. They don't have to really work in a silo. In a real world, they need to really work with each other, statisticians, mathematicians, domain experts, business experts, computer scientists, right, or a data engineer or a coder. They all need to really come together, but we can't really avoid a scenario wherein everybody has to really learn the coding, whether it's a creative director or a movie maker or an art or music composer, because everywhere the AI will help them to really augment their capabilities just like a god. With this note, I would like to really express my thanks to everybody, all the panelists, all the participants. The future is pretty bright. India government is at last is doing something good and trying to really ride on the wave of this global realization that they need to really just keep away from China as well, not too much of dependency. We need to really grab this opportunity. We have brightest engineers like Ravi and Anirudh, startup companies doing amazingly brilliant job, which we every day see in Aegis Graham Bell Awards. I'm personally very bullish, and I think all the panelists are bullish about India's future in manufacturing. And let us remove that notion कि इंडिया का ये एक्सपोर्ट क्वालिटी का प्रोडक्ट है सर, आप ले लो और घटिया क्वालिटी का प्रोडक्ट इंडियंस विल कंज्यूम. I think we should soon reach to that level wherein there's no differentiation in the product which is being offered to Indians or Africans or for that matter Bangladesh or anybody. We will have the equal access to the equal quality of the product, be it pharma, be it a car, or be it anything else. Thank you so much, everybody, for joining. Have a nice day. And those participants, you'll get the digital certification. Do keep on tap on the other events. We'll be coming up with events on data science, AI in telecom, BFSI, right, digital transformation. Please do join. Thank you so much. Have a nice day. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank
On
you.
behalf of Aegis School of Data Science, I would like to thank everyone who participated in AI and Data Science in Manufacturing Meetup. So this event was a great success, and it would have not been possible without the valuable contributions of all the dignitaries and attendees. So we would like to express our deepest gratitude to our keynote speakers who enlightened us with their expertise and knowledge. Their insights and experiences have certainly broadened our horizons and given us new ideas to explore. We also extend thanks to all other speakers and panelists who participated in other sessions and shared their valuable insights and experiences. So their contributions were again enlightening, and we appreciate their efforts. Finally, I would like to thank all the attendees who have attended this meetup. Your interest and enthusiasm have initiated us to continue organizing such events again. Once again, thank you everyone for your contributions and support, and we look forward to see you in our future events. Thank you.
Thank you, Ankit.
Thank you, Prof. Ankita. Thank you, Anirudh. Thank you, Ravi.
Thank you.
Thank you, sir.
Dr.